Hi there, and welcome to this three-part series on learning more about NVIDIA's Virtual GPU technology. With a lot of people working from home at the moment, I thought what I'd do is I'd run these webinar style. The first one in the series is going to be this video. In this video, I'm going to talk to you about why you need Virtual GPU, which is the right GPU for your virtual deployment, and which license do you need to cope with the number of workloads that you're using. This will be part one. Part two, I'm going to be going into how you size and troubleshoot a solution to make sure that you've got in the right performance for your users. And the third part is going to be some top tips that I have for you if you're running a POC to allow you to get a successful result at the end of it. Hope you enjoy the series of three, and let's just get into it. Okay, so the first thing I want to do is just go very briefly over some of the reasons and why people are looking to virtualize today. The first one, I don't think anyone would disagree with you right now. Working from anywhere and having business agility is actually really important to most organizations right now. The second one, of course, just because people are working remotely doesn't mean to say that you want to have data spread around all of their laptops at all of their locations. So centralizing all of that data and managing risk and managing conversations, transactions, that kind of thing from within the walls of your data center is really important. And the third one there really is around, having a workstation environment and having laptops strewn around all over your organization is an expensive proposition. So taking all of that infrastructure, centralizing it back into a data center and providing things for it like high availability, resilience, that kind of thing is really, really key to a lot of organizations. And it also saves a lot of money because of that levels of consolidation and virtualization that you're getting. So if you're deploying resources out to end users so that they can work remotely from anywhere, one way of doing it is with a laptop. If you try to move that into a data center, you could run into some problems with performance. The reason being, every laptop has its own graphics processor. You move that into the data center. Now, typically, virtualization infrastructures don't have any graphical resource available to process graphics and give the users a really good experience. So this is one of the reasons why having a GPU in that desktop can be very, very compelling. One of the trends we see is that Windows 10 is becoming more and more demanding on graphics over time. People are trying to compete with the likes of Apple in terms of a user experience with very, very nice, pretty graphics, lovely transitions, that kind of thing. So Windows 10 has become more and more graphically demanding over time. A lot of people went from Windows 7 to Windows 10 only to find that their virtual infrastructure was unable to cope with the same level of capacity that it had done in previous years. Also, the way people are working today is changing a lot. So forget for a moment the graphical demands of Windows 10 at all. Also, the applications that are running on top of that, even standard humble Microsoft Office today, you can now run graphics and animations inside of Word, for instance. So, a lot of this takes up demand and needs graphical processing power. Most people are using web browsers. Web browsers by default now have GPU acceleration built into them. And all of the websites that are being built as well have standards that will use and consume a GPU if possible. Collaboration and video, something that a lot of people are wanting to do. Obviously, the processing of all that video and all of those web conferences all takes its toll on the CPU of a virtual desktop. And probably one of the biggest factors that we see in virtualization, I see this more and more, is people are now moving to much higher resolutions of monitors. So whereas before the norm was maybe one high definition monitor, now we're talking 2 HD by default, probably 2 4K by default as well. So that is a lot of pixels that needs to be managed. And so virtualization in that kind of environment without a GPU can be very, very challenging. So just to give you a rough example, even Microsoft Office over time has evolved in the amount that it uses a GPU. You can see here are some performance statistics we have from Lakeside from 2017 and also from 2018. You can see there's been an increase there in the amount of graphics needed for all of these applications. So why do you need a virtual GPU? Well, the first one is pretty clear if you use a desktop with a GPU and without a GPU. You want to have a desktop experience for that user as if they're actually sitting at a local workstation working. Okay, you want it to be smooth. You want videos and graphics and animations to be very smooth at high frame rates. You want very good responsiveness from the desktop as well. So you want very low latency. So it actually feels more like a physical desktop rather than something that you're remote controlling from a distance. The other reason that virtual GPU is compelling is because it reduces the CPU load. Because it's actually taking the load off the CPU and actually processing that on the GPU, it's actually going to lower the amount of processing power that you need in your servers to some extent. You can see here probably around 33% lower CPU usage for some workloads if you have a GPU to help with the acceleration of that workload. Okay, so let's take a look at the professional technologies that we offer at NVIDIA. At the bottom there, I've called out some of the architectures we have. We started supporting virtual GPU with the Kepler generation, and we continue that moving forward to the Maxwell generation. We still have cards out there such as the M10 card. There's the Pascal generation. One of the most well-used cards there has been the P40. We have Volta generation. We have V100. Which was designed mainly around high performance computing and deep learning. And we have the latest architecture we have, the Turing architecture, which includes cards such as the RTX cards and the T4, which is our go-to card for general purpose virtualization right now. So on the left here, you can see we have the under the desk workstation products out there. We have our Quadro brand and we have our RTX brand. So these are graphics accelerators that are designed to sit in workstations and work on a designer's desktop, for instance. These cards are actively cooled, okay, so they have a fan in them and they can run on a wide range of workstation hardware. In the data center, we have our Tesla brand. Now, Tesla brands are our Tesla brand is slightly different. So these cards tend to be generally passive cards. So they rely on the cooling within the server chassis itself, which is why certification for each individual vendor is actually so important. We have blurred the lines a little bit with RTX, and I'll talk about that in a second. So on the left-hand side, as I say, Quadro RTX brands, you can see we've got a whole number of cards in here. This was just a random list of cards that I took off the website a few months ago. You can see we've got a wide range there for workstations, under the desk workstations. On the Tesla side, this is the cards that we support in our virtualization platform. So as I said, starting off with the likes of the M10 and T4 and moving right up to the RTX cards and the V100. Now, we're going to be concentrating on the right-hand side of this diagram for the remainder of this webinar. And really, we have two main areas where you would use Tesla cards. On the left of there, we have high performance computing and deep learning. People will typically be running this in a bare metal environment or maybe via GPU pass-through technology. So they'll be dedicating whole cards to individual workloads, probably running on some sort of Linux workload as well. On the right-hand side of the Tesla brand, we have desktop virtualization. So here we're talking about graphics acceleration, VDI, desktops, that kind of thing. And typically that will be done more often than not via virtual GPU, so splitting the card up into virtual chunks, or via passing that card through to the virtual machine if the workload is particularly heavy inside that desktop. Now, in terms of licensing, if you're running this card using the standard Tesla drivers, there's no additional software license required. If you're doing VDI graphics within this environment, there are a number of software licenses available for you, and I'm going to be talking about all of those as we go through today. Just another thing to point out as well, you might hear the technology on the far right hand side here referred to as vGPU, but you'll also hear it referred to as grid technology as well. Okay, this is virtual GPU technology. Okay, so how does this work? Well, in a standard server, you will typically put a hypervisor, something like XenServer, VMware, KVM, Nutanix, something like that. And then on top of that, you'll run all of your virtual desktops, which will have applications installed within them. Okay, So at this particular point, there's no graphical capabilities within those virtual machines, no graphical acceleration. If we move to how virtual GPU works, it's slightly different. So we have a physical GPU sitting inside that server chassis. It's typically certified for that chassis by the various vendor. We'll go through where to find that information out in a minute. The next thing we do is we put the hypervisor on top of that in the same way as we would do before, VMware, Zen Server, etc. And we install into that hypervisor something called the GPU manager. And that GPU manager takes care of splitting up that GPU between multiple virtual machines. Okay. As you can see here from this diagram, it's actually slicing this up in a certain way. So it slices it up using a dedicated memory portion or frame buffer for each virtual machine. Each virtual machine will get full access to that GPU and all the cores in that GPU based on a time sliced basis. So each VM gets its own time slice of the full power of that card, which is something to remember about if you start considering contention on that GPU as you're doing sizing. Now, on top of that, we then have our virtual machines. Within those virtual machines, we have the standard NVIDIA graphics driver, the same way as we would do on a physical workstation. It comes in a package, the virtual GPU manager, and the driver comes as a standard zip file on our virtual GPU portal, and that's where we definitely recommend you download the drivers for this type of solution from. Now, to the applications sitting at the top of this stack, they don't know that there's virtualization going on underneath. All they see is a GPU, the same way as they would do in the physical world. That means because you have applications that are certified for the Quadro driver, for instance, to work on a physical workstation, those certifications are actually much easier to manage and maintain in a virtual environment because it's using the same drivers. Now, another thing just to point out, I mentioned earlier on GPU pass-through. So this is where we take that GPU and we pass it at a PCI level using standard pass-through technology, or in Hyper-V we call it DDA, straight through to an individual VM. Now, this can be really good if you want absolutely top performance for that virtual machine, but it can be a little wasteful as well because really you need a virtual or a GPU, a physical GPU per individual user, and it doesn't scale as well. Also, you run into issues with this such as live migration. So if you're using virtual GPU on various platforms, you can live migrate a resource from one host to the other in the event of a failure, or you want to load balance those servers or something. You can't do that if you've tethered that virtual machine to a physical PCI GPU that's in the box. So that's just to bear in mind there. But the technology is there. I mean, the difference in performance between passing a GPU through via PCI pass-through and doing the same thing with vGPU, so giving it the whole GPU via virtual GPU, is negligible. It's a couple of percent in terms of performance difference. But just to point that out here so that you know. So what I'm going to do now is go through some of the various considerations that you might have when architecting a virtual desktop solution with vGPU. And I'm going to treat this a little bit like a pipeline. So this pipeline starts off with the GPU, goes through the virtual machine, through the various broker levels, through the various protocols that are happening for virtualization, into the endpoint, and then being decoded at the endpoint and displayed on the screen. So this is a pipeline. And to think of it like this holistically is an important thing because any part of that pipeline can have a bottleneck, and it's going to affect your performance if you have a bottleneck there. So let's start off right at the top of this. What do you need to think about? Well, the first thing to do is to make sure that the hardware you're using is certified for virtual GPU. Okay, and one really easy place to go to for that is our website. So if you go to certified hardware, you'll see here for all the various vendors we work with, we have certified hardware. It tells you which card are supported, how many of those cards are supported in these platforms, and yeah, just make sure your server's on here. Some of these servers will need a special GPU kit or a special cable to allow you to configure and power up that GPU. So make sure that you always have a server here and the right bill of materials when you're building your server. By the way, any link I put into this webinar, I will be sharing with you at the end via the description field. Okay, so while you're doing this, while you're figuring out that your server's right, another great place to go is the documentation. So go through to the documentation for Virtual GPU and find out if your overall solution is supported. So if you go into the supported products option here, it'll give you hypervisor, what versions are supported, what versions of what cards are supported, and what types of technology and which license. Okay, so it goes through in a lot of detail here. Another thing to bear in mind is if you go through to the release notes for each of your hypervisors, it gives you a bit more detail on what exactly is supported. And one thing just to point out here, if you're interested in knowing about Citrix apps and desktops, or Zen Desktop as it's commonly known, go to the Citrix hypervisor release notes, and that'll give you information about what's supported in the Zen Desktop area as well from Citrix. So the next thing to think about is which GPU is right for you. So there's a whole number of GPUs, as I've already said, and you know, this really depends on what applications your users are actually using in their virtual desktops, and whether and what type of users are they. Are they standard office workers, or do they do graphics for a living? So, you know, as I say, applications are really important, and really I've just created two buckets here that give you a rough idea of where you would land on as your choice of GPU. So if you have users that are knowledge workers, and what I mean by knowledge workers are those running standard Microsoft Office applications. They might have some very, very basic applications that they're graphically orientated. They're probably using a web browser. You know, they might be watching the news in that web browser. They might be browsing YouTube videos. You might have some compliance videos or training videos that you want to deliver internally. But they have some basic graphics needs within their virtual desktop. And then the other area I would class as people who provide and create and generate and view graphics for a living. Okay, so these are, you know, anything from designers right up to scientists doing sophisticated modeling. And we'll talk about that a little bit more detail in a minute. So knowledge workers and creative technical professionals. So with those two buckets in mind, we have a good choice, a good starting point for you of which GPU you should choose. So for the knowledge worker, our go-to GPU would be the Tesla T4. Okay, Tesla T4 is the latest generation, and it's a really good choice for virtualizing standard knowledge workers. We have another card that is pretty much specifically built for virtual GPU technology, and that is the M10 card. And the great thing about this card is it's got a big frame buffer. So it has a 32 gig of memory on that card, which means you can fit 32 standard Windows 10 users on that card with 1 gigabyte frame buffer each. And that'll give you good performance for, you know, 1 or 2 standard high definition screens. For the creative and technical professional, the T4 is also a really good starting point for those guys. So lower end graphical applications such as Autodesk would fit into that area really well. If you get up to the medium range, so say these guys are editing videos, you know, doing some basic visual effects, that sort of thing, or say they're in construction or engineering, something like that, then the RTX 6000 card would be the next place to go. Now, if you don't have RTX 6000 support in your hardware of choice at the moment, then P40 would probably be a good choice instead of an RTX 6000. But if you can get an RTX 6000 in your server of choice, then go for the RTX 6000. It tends to be about 1.5 times more performant, roughly, than a P40. It's slightly lower cost, and it's got the same frame buffer, so you can get the same contention on that card, same number of users. Now we go up past there, so RTX 8000 would be for people that are running very big data models. So it's basically an RTX 6000 with more memory. It's got 48 gig instead of 24 gig of memory. So really it doesn't mean you can put more users on that, because you always end up with this contention ratio of users on that card. Both those cards have the same GPU on them. But if you're loading very, very big data models in and you need very big profiles to allow you to do that, then the RTX 6000 would be a good thing for you. We also have the V100. That's really our top-end data science card. And you know, for virtualization, it's really at the top end there of what we provide. But for high-performance computing workloads that need to run on there, maybe under Linux, maybe you're using virtual PC or virtual compute server licensing, shall I say, then the V100 is a good choice for you too. So back to knowledge workers for a second. So these are standard office workers. So why would you go for an M10 or why would you go for a T4? So I've just provided you with a little Venn diagram here just to give you an idea of why you would use one or the other. I'd always say go for two T4s. They're half the size of an M10, so they can fit in the same form factor as a single M10. They take less power as well, so between them they only support, or they only require 140 watts of power, 70 watts each. They're the latest generation of cards we have up there. They're really good cards if you have mixed workloads, so hey, you have some knowledge workers and you have some higher end professional visualization guys as well. So always go with T4 wherever possible. Where the M10 shines is it's got a big frame buffer, and it's also lower cost than two T4s. Obviously two T4s, each T4 has 16 gig of memory, so between them they have 32 gig. Okay, the M10 has 32 gig on board, and it has 4 GPUs on that card as well, so your contention ratios can stay very good, and it has 32 gig of RAM, so you can fit 32 standard knowledge workers on there. So, you know, to sum it up, go with T4 where you can. If cost is the biggest option for you, go for an M10. Okay, so if your users are graphics professional and provide graphics for a living, then here's a quick ready reckoner for you to give you an idea of which is the right card for you. If you're using some standard applications like AutoCAD or Revit, the T4 is a really good area for you. If you're doing things like high-end CATIA workflows, maybe you're doing PACS, medical imaging, diagnostics, that kind of thing, then we're kind of in P40 stroke RTX 6000 territory, with RTX 6000 being the preferred card there. Go up to high-end fluid dynamics and video editing, visual effects, that kind of thing, then we're in sort of RTX 8000 going into the V100 range. But this is just a ready reckoner for you to refer back to later to give you a rough idea. Another way of looking at this here is to look at what types of workloads they're using. So light users, medium users, heavy users. So, for light users, people who are maybe viewing data models and not really editing them, just viewing that stuff, then something like a T4 or a P6, if you're in a blade form factor, would be great for you. Medium size assembly, again, a T4 going up there as well. Heavy users, we're talking about the RTX range of cards, P40, V100, that sort of thing. So here's just a quick diagram just to give you an idea of all the cards side by side, how many cores they have, how much memory, what profiles are supported on them, that sort of thing. I'm not going to go into this in too much detail, just to suffice it to say, we have the density cards over here for VDI, knowledge worker VDI, T4 and M10. The P6 right over on the right there, which is if you're using blade form factor, P6 is still a very good card. And then moving up to the RTX cards and P40, obviously with a preference for RTX 6000 over P40 there. And then right at the top, the V100 card as well. And as you can see, they all have different amounts of cores. They all have different amounts of memory as well. And just to point out, the core count here is important for various applications, but be very careful because most of these GPUs only have a single GPU on that card, with really the exception of the M10. So you don't want to get your consolidation ratios too high here because, each user is going to get a time slice of that GPU. And if you have too many users contending, your queue is going to be too long. Okay, so just bear that in mind. I'm also planning to do a webinar a little bit about performance testing as well as we go forward. So, watch out for that. I'll be talking about that in a bit more detail later. Okay, so here's the stack. I went into my lab a couple of months ago and took all the loan cards out of my cupboard and actually put them in a stack here so you could see them all. So you can see down at the bottom here we have the old back in the day cards, the K1 and the K2, the first couple of cards that we provided for virtualization. We have the M10 here, which is still a very good card for general purpose knowledge workers. We have the M60. The M60 was the predecessor to the P40 for general purpose CAD workflows, that kind of thing. We have the high-end card. It was originally a P100 for Pascal generation. Then we moved up to a V100. I've got an RTX 6000 there as you can see. There above it, you've got the P4, which is the predecessor to the T4. The T4 being a much smaller form factor card with much lower power consumption as well. Another thing to point out on this diagram here is if you look at the cards at the back where the power connectors are, obviously the P4 and also the T4 don't have any connectors. They just take power from the PCI bus itself, but all of the rest of them have completely different connectors. So be slightly careful if you have a machine with, say, a P40 in it and you want to swap that out for an M10 or vice versa. That's a different cable. Okay, it's got a different plug on it. They take different power draws, so be a little bit careful there that you don't think that you can just swap one card in and one card out without doing some due diligence first. But there's the stack, just so you can see what this stuff looks like in the flesh. Okay, so now we've decided on which GPU is going to be right for our workload. Next thing we need to do is decide which remoting stack we're going to use to get those pixels from the data center down to our end users. A couple of different things to think about there. Okay, so first of all, just do a quick check in your matrix here to make sure that your remoting stack is supported. So typically we see that people will either deploy Citrix Zen Desktop or Virtual Apps in there, or Horizon. We also have customers out there that are using things like Teradici as well for certain high-end video-based workflows. But you know, the two tend to be Citrix and VMware in the market right now. Also, let's just spend a couple of seconds just talking about the differences in remoting technologies out there. So you have two different models broadly on how you deploy a virtual desktop. One will be a server-based desktop, so it will be based on what most people call RDSH or terminal services. So you'll have a Windows 2016 or 2019 server, and you'll put multiple user sessions onto that. The way we tend to advise people to split up the GPU resource for these is go with quite a large frame buffer. So something like an M10 card has got 32 gig of frame buffer, as we know. So split that 4 ways and have 4 XenApp servers running on that. That will give each XenApp server its own virtual GPU. Okay, so that's one way of doing high density desktops. Typically for lower end applications and lower end users, mainly knowledge worker type workloads. For all the rest, we typically see a Windows 10 desktop, a dedicated desktop per individual user. So your frame buffer count that you allocate, your profile that you will allocate to each user is much smaller than you would do typically for a Windows 2019 server, for instance, because you have multiple users on there. So instead of using a frame buffer of say 8 gig, you would be using something like 1, 2 or 4 gig, depending on what your application is in there. So, remoting solution selected. The next thing to think about is what virtual GPU license should you buy for your workflow. So, as I mentioned earlier on, there are two components to this. One is the physical GPU and the other one is the software that runs on top of that stack. That includes a driver, that includes the GPU manager and also a license server as well. So there's a license server that runs. When a virtual desktop comes online, it will consume a license from the virtual GPU license server. When you switch that desktop off, it'll actually take that license and give it back to the license server. It's not relevant to users when they're logging in at all. It's literally when you turn the virtual machine on, it will get a license and it will consume a license. So which is the right license for you? So we have licenses for all different types of application. First of all, down at the basic level, the standard knowledge worker level, we have two licenses. One is called Virtual PC and one is called Virtual Apps. Virtual Apps is if you're running RDSH workloads on a server. This is done per concurrent user, okay? So however many concurrent users you have on your XenApp or Horizon Virtual Apps server, that'll be the number of users. So your high watermark of number of users you have on that server. That's how many Virtual Apps licenses you'll need. The other license is Virtual PC, and this is for standard office worker VDI desktops, okay? It's, again, a single license, but instead of doing it per CCU, we're actually talking about how many concurrent desktops are running on a hypervisor at any given time, Okay, so concurrent desktops, not necessarily concurrent users. What you could have is a desktop that services multiple users. So, you know, in one part of the globe, someone could be logging into it during a certain time frame. They could log out, and another person from another time zone could log into that desktop as an example. That would only consume one license because there's only one desktop active and one GPU profile active. Okay, so that's knowledge workers. For graphics professionals, we have what we call our Quadro Virtual Data Center Workstation license, or QVDWS. Okay, this gives you higher performance within that virtual desktops. It gives you access to things like CUDA, language for application acceleration. And a lot of applications will use those calls by default. It has higher frame rates. For instance, the virtual apps and virtual PC license will limit you to 45 frames per second on your virtual desktop, which is pretty good for a knowledge worker. But for creative and technical professionals that need slightly higher smoothness, slightly better smoothness when they're rotating graphics, that sort of thing, then we can go up to 60 frames a second in that license as well. Okay, you can have more screens, bigger frame buffers, all that sort of thing in the Quadro Virtual Data Center Workstation license. So the last license type we have is something that's relatively new to Virtual GPU. It is our vCompute server license, and this is for users that don't want graphics on their virtual desktops at all. It's not typically used for VDI use cases. It's for those that want to split up a GPU and get all the benefits of virtualization, but they'll be running things like artificial intelligence workloads, data science workloads, or high performance computing workloads on there as well. Okay, if you want to find more about our licenses and which is the right one for you, I've got a link down the bottom, and I'll also put all the links down in the description field below for you to have more information on this. But just, suffice it to say, we have 4 licenses. 2 of them are for knowledge worker, 1 is for graphics professionals, and 1 of them, the vCompute server, is for data scientists and deep learning professionals. So just a quick decision matrix for you here. Do you have any high-end professional users that are using CAD applications, engineering applications, doing rendering, and that sort of workflow? Okay, if you do, then you'll need a Quadro VDWS license to service those applications and an application set. Something to bear in mind as well is with Quadro, you also get all of the other licenses under that. So you get a virtual PC license, a virtual compute server, and a vApps license for that individual person, for that desktop. Okay, so you could potentially use that license in different ways. Okay. Do you have a VDI desktop with standard office workers that need a native-like PC experience? Well, if that's the case, then you need a Grid VPC. And of course, with Grid VPC as well, we also include the lower license underneath that. So if you have, for instance, a user that logs into a Windows 10 desktop and then they consume apps in the back end from a XenApp server or something like that, then that's just a single entitlement you need for that user, because that vApps entitlement comes as part of your VPC license. The next question is, do your users have multiple sessions? Do they share multiple sessions on a single server? So are they RDSH type workloads? If that's the case, then you just need a standard Grids vApp license for those. And of course, finally, are they running artificial intelligence? Are they doing deep learning? Are they doing inferencing or even deep learning training? Are they doing high performance computing? Then in that particular case, you need NVIDIA vCompute server in there as well. Okay. Any more questions? If you're not a partner already and you're an end user, go and talk to your NVIDIA partner about this. Okay, so now you've chosen a GPU, you know what license you want, you've got a good handle on what your users are, what applications they're using, and you know what remoting technology you're going to use to do this. And the next thing to talk about in a little bit of detail is something called profiles. And profiles are the way that we access the GPU and the way we split up that virtual GPU between multiple users. So the first thing I want to do is just introduce you to what profiles are, and you'll see these profiles on your hypervisor management tools when you go to allocate a virtual GPU to a user. So here's an example of a standard profile. This one's a T4 1Q profile. So T4 is the card, obviously. The architecture, as you can see here, T for Turing. Okay, so that's our latest architecture. The next name of that profile is 1Q. So 1Q would be the frame buffer size. So 1 gig in this particular case. If it was a 4Q, it would be a 4 gig frame buffer. And at the end there, you've got the license type that you're using. So A for apps, think of it that way. B profile is for business users, so standard knowledge worker users. C is for virtual compute server for deep learning and high performance computing workflows. And Q is our Quadro VDWS license. Okay. If you want to find out which profiles are supported and which how many screens and what resolutions, that kind of thing, just go to our latest documentation guide. It'll give you an idea for each profile on what's supported. Be slightly careful here when you look at how many heads are supported, how many display heads and what resolutions are supported, because just because, for instance, it says that we can support 4 virtual display heads all at 4K doesn't mean to say that you're going to get a great performance on that. It's basically 4 display heads, and the maximum resolution any of those can be is 4K. So the best thing to do is to test out the profiles. Start on a medium range profile, see what the performance is like on that. If it's good, then move down to a lower profile to give you slightly better density. See if that works. Work out where the breakpoint is and where performance starts to tail off. Okay, but you can use multiple profiles to allow you to do that. So now I want to talk to you about remoting protocols themselves. So one of the main things that I see when people complain of performance issues with their virtual desktop deployment is they haven't treated the protocols that they're using and haven't put a lot of attention on tuning those protocols. So we don't have a lot of time to talk about all the various protocols out there. There's loads of them, like PC over IP, Blast from VMware, HDX from Citrix, there's the Teradici protocols as well they have out there, and they all have various different tuning parameters. What I can do though is point you to a really good article that one of my colleagues in Germany has actually written. There's a whole series of 6 articles here about how to use different protocols. So when is the right time to use a standard bitmap protocol to send screens down to that endpoint, when to use the video codec, and some of the trade-offs that you need to make with each of those. There's an set of articles there, 6 of them, very, very useful thing to do. Now, just if you're coming from a Citrix world, just to give you some idea of how complex some of this stuff can be, here is a chart for using the video codec with compression. Video codec with compression means that you can use the NVIDIA GPU on most versions of XenApp and XenDesktop to accelerate the encoding of that protocol on the VDI, virtual desktop, before you send it to the endpoint. So it's a great thing to have. But as you can see here, you know, there's quite a lot of choice to all the various policies you use, and depending on which policy you use, some of them will counteract each other, and you'll end up with a slightly different set of protocols on the endpoint as you go forward. The next video, we're going to talk about some of the tools you can use for tracking some of this stuff and changing stuff on the fly. Some really useful tools like Remote Display Analyzer, so watch out for that. So just a few areas that I want to touch on before we finish this webinar. One of them is network bandwidth. So to provide a high performance accelerated graphical environment down to a user is not a trivial task. If you're on a standard network, you tend to have no particular problems with bandwidth. If you're trying to do this remotely, it is a big factor, okay? Most people have quite good internet connectivity right now. I've been speaking to users recently. I know people that have moved their radiographers, a certain hospital in London that's moved their radiographers out to home so they can actually report and do diagnosis using PACS applications, you know, X-rays, CT scans, that kind of thing. They can do all of this from home. So they need to make sure that they set up a decent network connection between the data center and that end user to make it happen. But it is eminently possible. And I've even heard of people reporting from Australia. So they've had radiographers in Australia and they've been reporting on cases from an office in London. So it is absolutely possible to do. We tend to find that with slower connections, what we need to do is make people slow down a little bit. It's not going to be quite as quick. It's going to be slightly laggy. We can't change the speed of light. There's always going to be a bit of latency there. But typically, you know, it's something that a lot of people want to do right now. Course. So just think about the network bandwidth between your end user and your virtual desktop. Another thing to point out here is we've seen issues where people have been complaining that their virtual desktop is very slow, but when we've looked into it in more detail, we found that the endpoint hardware that they were using was not capable to cope with the amount of pixels being sent down to that end user. Okay, so make sure if possible that you've got a high-end thin client or a PC sitting at that remote endpoint, something that has some capabilities, maybe hardware, H.264 or H.265 decoding, that kind of thing, just to make sure that the bottleneck doesn't end up being the endpoint. And also another thing to be aware of is the more monitors that you have at your endpoint and the higher the resolutions are, the more data needs to get sent down that link. And, so make sure that if you're doing it over slightly slower connections, make sure it's just 1 HD or 2 HD monitors you're trying to deliver, not, full color 4K monitors down at the endpoints there. So just something to bear in mind. If you're running into any problems in any part of this pipeline, one good way of doing it is to do things like, if it's running slow over 2 monitors, go to 1 monitor, see if the experience changes. If your thin clients are running slow, just put a standard PC in there just temporarily, just to see if performance gets better. If your network bandwidth is something you think is a problem, then go into an office where you can and try it from within there to see if that was the point that the performance got better. So all of this, as I mentioned, it's a pipeline, and all of this pipeline has to be optimized in order to get a very good end user experience for our users. Now, a couple of other factors that we're going to be talking about in our next video is around monitoring tools and density. Okay, so obviously density is a big thing. You want to get as much bang for the buck as you can out of your GPU, but not at the expense of performance. So I'm going to be giving you some strategies on how you can go about doing that. Also going to be giving you some information on monitoring tools that you can use to monitor your POC as you're putting it in, to track what the GPU is doing, how heavily utilized the frame buffer is, that kind of thing. Okay. And down the bottom, what I'm going to make sure I do in this video is give you some of the greatest links you can go to find out more information about this stuff. Some of the ones I definitely recommend is the main vGPU documentation. Always go there. It's got all the versions of Grid on there of virtual GPU. Is your hardware compatible? The link that I called out earlier to the vendor sites. Is your software compatible? That's in the docs as well. There's a licensing PDF you can download to see which is the right license for you. You can get a 90-day evaluation license. Okay, so just because you need licenses, you can actually work for 90 days. We give you 128 licenses by default. In some cases, you can actually apply to get even larger numbers of licensing at the moment. You can go to the software download. Always make sure that you download the software for virtual GPU from our NVIDIA licensing portal. Don't be tempted to go to nvidia.com/drivers and download Windows drivers from there, because they'll typically be the Tesla drivers that are designed for bare metal and won't work in a virtual GPU environment. There's a document there on Windows 10 sizing if you're interested in that. There's also some deployment guides on the right hand side there for Citrix and VMware installations, which are step-by-step documentation. There's information on the license server there as well, how to set that up. I've also done a video on that, so I'll give you the link below to show you a step-by-step guide of me installing the license server, so you can get that up and running really quickly. Two of my favorite tools, GPU Profiler and Remote Display Analyzer. We've talked about those a little bit, and I'm going to be doing a specific webinar on that shortly. And some bedtime reading for you, some more white papers to think about when you're thinking about deploying virtual GPU. Okay, well, I hope you enjoyed that webinar. What we covered in there was really the importance of how to take the whole pipeline, if you like, between the user and the server, and think of that as a whole workflow that needs to be optimized in order to get the best performance. We talked about which GPU you should use for various different workloads and which is the right license to use, again, for those workloads. That was part 1 in the series, and the next thing we're going to do is go into part 2, which will talk a little bit more about how you can do troubleshooting and sizing using some very common tools that we have out there. So thanks for listening, and look forward to talking to you in the next webinar.